In the previous video, we looked at an absolute value equality that had a lot going on. So in this video, I'm just going to take it from when we got the absolute value by itself, and we're going to look at it as an inequality. So the first thing that we need to make sure is that the absolute value is alone. So the absolute value has to be alone. So once I know that, then I can go ahead and start thinking about solving for x. The other thing that I want to look at is my inequality. So when I look at that inequality, I'm going to read my equation for my inequality, and I'm going to say, I don't care what's inside right now, I'm just going to say my absolute value is great or, and I'm just going to stop there. So notice how I mispronounced or misspelled greater for great or. That tells me this is an or, which means it's going to be very similar to setting up my equality. So again, I'm going to have my case A, that's going to be my case B on that side, and my case A over here. So I'm going to copy this. I'm going to bring it down without the inequality. I'm going to say x minus 3 over 2 is greater than 4. But this side here is a little tricky. We have to be careful with this side. I'm going to copy what's on the inside. X minus 3 divided by 2. And this is where this gets tricky. The left side I'm always changing. So I'm going to switch my inequality and make this say negative 4. That's very important, and I want you to highlight that this here is what gets changed. Okay, so now just like what we did before, we're going to do simplifying. So I multiplied both sides by 2. And again, I can do that to both sides simultaneously. You don't have to. You can do one side at a time. And then that means now this divides out to 1. So now I have x minus 3 is less than negative 8, or this divides out to 1. So I have x minus 3 is greater than 8. Notice that the same math applies. I'm going to add 3 to both sides because I want x by itself. So this gives me 0, so that gives me x is less than negative 5, or x is greater than 11. So you can see we got the same numbers, but we have these inequalities which make things a little trickier. So I'm going to put my number line. I'm going to mark on there where my negative 5 is, where my 11 is. Because I do not have an equals there, I have to put an open circle. If there were an equal sign there, I would fill in the dot. Now, where is x smaller than negative 5? Well, these numbers get smaller as I go to the left. And where is x greater than 11? Well, this is 12, 13, 14, so all those numbers there. So what this is saying is that any number that I put in for x has to be less than negative 5, or it has to be greater than 11 in order for this absolute value to be true. Let's look at a slightly different problem. So if I have the same inequality, but this time I change my inequality to be less than. So again, this is a different problem. So I'm going to separate it. Okay, so again, I have to pay attention to what type of inequality I have, and I have to make sure my absolute value is alone. So I'm going to write here that my absolute value is alone, which means I can go ahead and solve it. And now, when I read this, I'm going to say that my absolute value is on the small side, so is less than, do you see what I'm doing here? So that is an and. So with ands, there's two different ways we can go about doing it. Let's go ahead and set it up the way we've set it before, and then I'm going to kind of switch it up a little bit. So we can go ahead and take this out of the absolute value. We're going to go ahead and have a case A. So remember, my case A is always changing on me, and my case B. So my case B is going to be what I see. I'm going to take it out of the absolute value. So that's x minus 3 divided by 2 is less than 4. My case A is the one that switched, so that's going to be x minus 3 divided by 2. I'm changing my inequality because I'm changing my 4 to a negative 4. Okay, so this is an and. So let's just think about this for a minute. Negative 4 is smaller than 4. Okay, so I'm going to give you a little visual over here because I'm going to show you how I'm going to set this up a little different. So this is negative 4 and this is 4. So you agree that negative 4 is less than 4. So let's just look here. What's less than 4? Well, x minus 3 divided by 2 is less than 4, isn't it? Well, wasn't x minus 3 divided by 2 greater than negative 4? Isn't x minus 3 divided by 2 greater than negative 4? So I can take this and make it what's called a compound inequality. And I'm going to do that just because it makes it a little easier to solve. So I'm rewriting my and like this. You don't have to. You could still do it separately and you'll get the same answer, but you have to do a little bit more thinking. So that means I'm going to have the same operation happening in 3 places. So notice where my x is. My x is here in the numerator. It's being divided. It's being grouped by that division sign. So that means I'm going to multiply the inside by 2, because I have a 2 in the denominator. I'm going to multiply the left by 2, and I'm going to multiply the right by 2. So that means I have 2 times negative 4, which is negative 8, which is less than, that divides out to 1, x minus 3. Okay, so now I'm going to go ahead and I'm going to add 3 to all sides. So that means then that I have negative 5 is less than x is less than 11. So what's nice about writing my answer like this is when I go to put it on the number line, I'm going to put my negative 5 there. I'm going to put my 11 there. Because there's no equal bar with that inequality, I'm going to leave it an open hole. Where's my x? My x is in between. So my x is in between, which means my solution is in between. So you could have come to the same conclusion if you kept these two and worked them separately, but when you came to the graphing, you would have had to think about it a little bit harder. and that's why I went ahead and made it into a compound inequality.